Alright, hello everybody. I wanted to make a quick video to help anybody that was trying to troubleshoot ignition on their outboard motor. This is the 1991 Johnson 200 horse engine. First thing I would like to share with everybody is a couple of lessons learned that I had from doing this job, and I will then take you through some of the things that I had done, the way that I had tested, and hopefully it helps you out. So I learned late in the game that buying an $8 starting switch helped out a ton, and when you get it, it just expects you to know how to use it. So looking at some forums online, I took a look, and so I thought I would share with how to hook this thing up. So on my motor, my solenoid is right here, and so I followed the battery cable up to the solenoid, and that's where one of them has to go. So I just clipped it on there like that. So there's three other options that you have. One is to go right around to the other positive cable, which is not going to help you out much. There are two other switches on here. One goes to ground, that's not going to be helpful. And the other one is on mine, you can see there's a yellow and black wire here. It doesn't go to ground, it goes as a start switch. And so when you clip this on, this does the exact same thing as your start switch would do. And now I can use this button to start to rotate the engine, so I can start troubleshooting my ignition. So this was a huge help when I was starting to troubleshoot spark. Recommend getting one of these if you're having any problems. It'll save you a ton of time trying to go back and forth from your key switch. Another tool that I found extremely useful is a spark tester, and since I don't do a lot of spark testing, I don't prefer the ground it against something or use your spark plug and ground it so you can see a spark. I like something that you can see into as you use your trigger and turn the engine. This is a really easy device to use. You just take one of your spark plug wires, plug this side into it, and then this side goes to the spark plug. Slide that over the spark plug. Then all you have to do is, when you use your ignition switch, is look in this little light, and if it's blinking, then you have spark. If it's not, then you need to continue troubleshooting. Put that back together. If you look at a lot of YouTube videos about how to troubleshoot or fix ignition problems, you'll start to see that you'll see some blue parts in here, and those are the CDI parts, because a lot of these parts go bad. And so the original power pack was black, and the original stator, obviously it's going to be wires, but the timing base is also black. So when you look on YouTube videos and you're wondering if you need to spend a couple $100 on a power pack, or a couple $100 on a stator, or a couple $100 on your timing base, take a look. These things do go bad, and there's a good possibility that yours is bad if you're not getting any spark. So don't be shy, or don't think that you did something wrong, because it's worth it. If you've hooked up and you've seen that your parts are out of spec, then they probably are, and they need to be replaced. So a couple of problems that I had run into is, on this particular model, is that the nut on the top of the flywheel, when you go to remove the flywheel, is a 1 inch and 7/16 bolt. And almost every tool store you go to, the 1 and 7/16 is a 3/4 inch drive, and that 3/4 inch drive ends up making the metal a little bit too thick and won't fit down in that hole. And so I ordered a couple, and I'll go get them. So I have 3 here. This one, 3/4 inch drive, and so the problem is that the wall thickness is too thick to actually reach in to go down in here. It's too thick. I can't turn that bolt. So then I went and got a a 1/2 inch drive because I thought, well, 1/2 inch drive should have a thinner wall than the 3/4 inch drive. So it's about the same wall thickness. And just like you would imagine, it was also too big. So I went to O'Reilly's, and they were the only parts store that has, this is a Power Torque 36 millimeter, and that's about the equivalent of that 1 7/16, and it actually fits. So yeah, it's not the best, but you shouldn't be putting on and taking off that bolt that often. So what I ended up doing is using this to take off the flywheel. Another important piece that you need to take off the flywheel, if you haven't ever done it, is a cheater bar. This thing is about, I don't know, 5 foot tall, and I was at the very end of it with a breaker bar in order to break that top nut. So if you haven't taken your flywheel off before and you have an older bolt like I do, I took a tremendous amount of torque to get that particular bolt off. The next thing that I would like to show you, or show a lesson learned about, is there's a couple of different ways that people recommend to get the flywheel off or to lock it down. And so I didn't have something to help me to turn against. So what I saw online was to use a chain. And so what I ended up doing was there's an empty hole over here. I put a bolt here, and then depending on which way I'm turning, I just put a screwdriver through one of the holes up here and held it in place, and that worked perfectly. I had no issues using that chain. So I would recommend if you have a chain, use that. Thing is that I didn't want to spend $300 or $150 on a flywheel puller, and so what I ended up getting is this harmonic balancer puller, and it came with some cheap bolts. And so I went to Home Depot and got a couple of the same size bolts. I think they're 5/16, and I used their washers, but the bolts that were included in here I think are too soft, and we would end up screwing yourself over if you used them. This is a nice steel bolt. I just dropped it in there, you put it on top, and then you crank and crank and crank and crank, and it ends up popping off. Had to use quite a bit of torque on that also in order to get it to pop off. And as everybody has said online, it is quite a violent process. So it's don't be scared that you're going to break something. Just be aware that when it pops off, it will shock you and kind of scare you. So what you end up doing is you take that top nut off, you put that harmonic balancer, use those screws. There's 3 screws in the top. Grab a wrench or your breaker bar that you use to take this nut off with to begin with, and start turning, and eventually it will pop off with a large amount of force. It'll scare you, but it comes off, and there's no harm once it comes off. So first thing I did was take a look underneath the flywheel and make sure there's no damage to the magnets underneath, and which there wasn't. There's 4 bolts for the stator. Take the 4 bolts out, the stator pops right off, and then there's 2 screws for the timing base, and then the timing base will come out. So just be careful that the timing base has a plastic ring, or the original one has a metal ring that it slides on, and make sure you grab that, because if you don't, then you can't put the new one on. The last piece was the power pack. The only gotcha or surprise that I have with the power pack is that these kill switches here did not come with the bushing that goes to the other side, and so actually it's here. And so what I ended up doing is, on the old power pack, I just pulled this off, got some dielectric grease, and then pushed it back through. So I had a nice insulated connection right there on that switch, and then there's also another switch on the inside. Actually, I think this is as a heat sensor, but yeah, both of these on both sides did not come with that plastic sleeve, and so I just pulled it. Like I said, you just pulled it off and dielectric grease, pushed it in. I had no problems. So the next part of this video is I will show the verification methods on how to test my broken stuff, so you can see the values that I was getting when I did my testing. So if you're getting similar values for resistance, your stator or your timing base is probably broken and you need to replace it. So let me get set up over on my table and get my voltmeter out, and I'll show what's going on there. All right, I did want to show a couple of things on timing, and so I'm going to be doing this with one hand, so a little bit of free hand. So as I had mentioned before, this is the new timer base that I had installed, and it's blued, like I said, so you can see that I replaced the timer base and the power pack. I read online that generally people will replace the power packs along with the timing base. I didn't want to take any chances and with a new timer base or a new stator causing any problems with my power pack, so I just went ahead and bought both pieces because I don't want to be out in the water and something blow up or something and I'm stranded. So what I did want to show is that some of the things that I had some problems finding is, or in the service manual, it's talking about stops. And so on my particular motor, this was my idle adjustment screw, and so this ends up just stopping it meaning the forward advance as you come into neutral at a higher RPM. So I had adjusted this today. Down here is the wide open throttle, and it's, in my opinion, it's easy to find because this one on top is the stop when you're actually at full stop with the throttle up, and then as you push the throttle down, this is the one that stops here to prevent you from pushing too far forward. So it made more sense when I actually looked at it. So imagine if you have a Johnson motor, it looks sort of like this also. So that's, I hope that was helpful. So the next piece I wanted to show is the spark adjustments, and so there's two of them in there. And so the one on the starboard side, he is the one that does your wide open throttle spark adjustment. And so there's a bolt there to keep it in place. As you turn it in or out, that'll adjust your timing when you're at wide open throttle. And so they do recommend that you go into a test tank at 5,000 RPM, which is hard to achieve by yourself. But I left mine on the trailer, got it up to about 4,000 and checked the timing, and it was good at the original setting, which was surprising. However, on the other side of the motor, there is the idle timing, and I was able to get that adjusted today by myself pretty easily. So the other piece to look at is on my particular motor is they had already had the timing marks done, and so top dead center was here. You can see that it's marked with TDC. This particular motor is between 16 and 18 before top dead center, and for the full open throttle, and then it's 4 to 8 degrees after top dead center for the idle mark. And so it's timing to me before doing this project was a mystery, but what you end up doing with your timing light is it's just a strobe that flashes as soon as the number one cylinder fires. And so what that strobe allows you to do is see those white marks that I was pointing at, or if you didn't put them on there, it allows you to see them. And so all you have to do is point that timing light at this mark, because that's supposed to be where top dead center is at, and as that mark comes around, if it's before or after, you adjust these screws and it moves it forward or back. And that's really all there is to timing, is getting your light, put it on those marks. You already have it marked at the, you know, on the top. Use some sort of reflective paint or white marker like they did for me, and adjust those screws until it's there. There's one more thing I'd like to show you about timing lights. This particular timing light I got from Harbor Freight today, and unfortunately right as I finished the timing, it had stopped working, but I did get it done. So one of the things is that you see that on this light there is this thing called advanced degrees, and so one of the nice things you can do is that all you have to do is set this to your engine's advance. Say mine was between 16 and 18. You put 18 on there, and then as the mark for top dead center comes around to that one white mark that I had here for top dead center, since I already had set the advance, all I have to do is look for TDC to be here at this, and that will set it for you. So it takes some of the additional guesswork of looking on your wheel and making multiple marks and getting yourself confused, whereas you could just have one mark at top dead center, set your timing advance to what it's supposed to be, 18 in this case, and then top dead center it will flash top dead center when it's right here. Alright, so got everything set up, and first I would like to mention some of the equipment that is required. First, CDI actually provides a guide on and to tell you if you purchase a new one, but you can also find this online. But the most important section is this section, and that will tell you the resistance levels or DVA readings that you need. So one of the things I wanted to mention about DVA is basically that you need ability to check out peak voltage. And so what I had originally done when I had started this project was, well, I don't have a way to do peak voltage, but I do have a way to do voltage. So I hooked it up, and my stator came in at showing 130 volts. So on this particular sheet, it says that I need to be producing 150 volts or more when it's connected, or 170 volts when it's disconnected. So I thought, oh well, my resistance values are bad and the voltage production is bad, and so I bought a new stator. Not to say that was a bad idea in the long run, but that was not the problem that I was facing with this particular problem. So what you need to get is either a couple $100 fluke or something that does peak voltage, or a $20 device that does DVA voltage. And so CDI produces one that is $140 for this little piece. There are several guides to making your own. So if you have a bunch of resistors and capacitors sitting around, then you can make your own. Or if you don't, like I do not have a bunch of those particular components sitting around, I went to this company, RM Stator. You can go to their website, or I went to Amazon and got this one. And so this one was $20, and it worked just fine for what I was trying to do. So in order to use this, all you have to do is replace your traditional leads with the leads coming from this, and just like last time, as we go negative and positive, red and black, and then these guys go to whatever you're trying to test. One of the important things is that even though that your stator is outputting AC voltage, this particular device rectifies it. So there's a rectifier in here that will bring it back to DC. So if you're using one of these and you're trying to check voltage, you need to go to the DC voltage side and not the AC voltage. So that was an important part that took me a little while to figure out, was the fact that there's a rectifier in here. Rectifiers go from AC to DC. Set your voltmeter to DC, and voila, it works. So Next thing I'll go over is the other piece that you need is going to need some sort of test clamps. And so I got these from Walmart. These were a couple bucks. I keep them in my boat usually because it's 1991 bolt, and I need to test things quite a bit. The other thing that I did, and the video that I watched, and I'll probably link in this description, because he does an outstanding job of doing the actual testing. So no need to reproduce that, but he suggested to use a piece of paper between your leads so they don't touch when you're trying to test something. What I ended up doing is I just put a piece of electrical tape on here. It was less frustrating than the paper method, and I'm still able to have some flexibility in clamping these onto those posts. So I recommend getting a small piece of electrical tape and using that on one of your particular clamps. So let me get one of my old parts that I pulled out of my boat, and I'll show you what I was experiencing and why I replaced it. So here is my old timing base, and so earlier I had mentioned that there's a metal or plastic piece that goes around the bottom of the timing base, and you can see it's right here. So this plastic piece. When I put my timing base in, I left it on. I just made sure that there's a small race on the inside that you need to make sure that this clips into, because the timing base has to move freely, because that's how it adjusts. This particular device is how it adjusts your timing. And so when the boat or you move the throttle cable forward and the RPMs go up, this needs to advance the timing. And so what ends up happening is this is also tied to your throttle linkage, and it starts to pull it forward, and that advances your timing. So that, what I mean by advance, is it starts to fire the spark earlier in the as the piston's coming up. It fires it earlier in the cycle than when it does at neutral. So, or excuse me, not at neutral, but at neutral. And then so you start to give it more gas, this thing turns and turns, and it's starting to advance the spark. Just like, think of a distributor. If you ever did timing on a distributor, you move the distributor and that moves the spark. Same concept here, except that you're actually moving this with the throttle cable. And that's why they say, or in the videos that you watch about this online, is it says make sure that this piece can rotate inside of your boat. So that's what I had learned as I was doing this particular project. One is, I had mentioned those two bolts. Well, those two bolts for timing adjustment are the two bolts that stop this. So as it returns to neutral and you're starting to idle, there's a bolt that hits this and prevents it from moving back any further, and that's setting your timing advance at neutral. And then as you put it into gear and it starts to turn, there's another one that hits on the other side and stops it. So, and that would be your maximum advance. So I don't know if that made any sense to anybody. I don't think it really makes sense until you actually do it, but if my words help, or maybe it's something to look for when you go do it yourself, but it's a little bit confusing for everybody. So the other differences between the OEM piece is these little wings are plastic on the CDI, and these are metal on the OEM part that came out of my boat. So I think I might have found one of the problems. This is cracked down here, probably due to heat and some age, and probably caused some resistance problems. So let me start with the stator, and we will go over how I tested the resistance values on this stator. So, all right. On the spec sheet that you get from CDI, or you pull it down online, you can see there are resistance values that it wants to see. And so there's two columns. There's the one of the leads that you need to check, and the other lead that you need to check. So in this case, it says brown wire and brown yellow wire. And so on the stator, you'll see that there is a brown wire, and then there's a brown wire with a yellow stripe. So you know that your two leads need to be clamped onto here. And so that goes back to the point of why I said that you needed this tape on your leads, because it's very narrow in there. So what you do is you just take your lead and you clip it in there, and you take your second lead and you clip it in here like this. And in theory, and we'll check here in a second, these two shouldn't be touching, and then we can check the resistance. So the resistance on this should be between 850 ohms to 1100 ohms. And so I'm going to set my voltmeter for the 2K range. And so if you're fancy enough to have a auto sensing voltmeter, then it's awesome, but I do not, so I actually have to set it myself. Just attach my black lead to the black side, or it doesn't really matter, but just to stay consistent, and the red to the red. And you can see that this came in at a little bit below spec on this side. So in order for the stator to have passed, the resistances should be between 850 and 1100, and they're at 787. So a little bit below spec. Probably it would still be working, but not for long. And you can see on this stator that it's starting to bleed a little bit. You can see that the insulation is starting to come through the coils, specifically here and on the other side. So it was just a matter of time before this guy was going to go out. So it's probably good that I replaced it now. So to check the other side, you're supposed to check the orange and the orange black wire, and that would be these guys. So there is a orange wire and there is a orange black wire, and the resistance there is supposed to be between 93 and 100. So take these out, grab this guy here, and grab this guy here, and adjust that a little bit. And so these wires are actually within spec, and so it's at 97.7 here, and so this one is actually within spec. So like I said, the stator probably could have lasted a little bit longer, but I went ahead and replaced it anyway. So anyway, that's how you check the stator. The next piece is that if you had it on the boat still, we would use this device here and check it when we use our starting switch. We would move those magnets around the stator, and then we would check the voltage. And we would see that that this particular stator came in a little bit on the low side. It was about 145 volts. Still probably okay to produce spark, but like I said 3 times now, I've replaced it anyway. So let's move on to the timing base, and in this case, the timing base was what was wrong with my particular boat. And so unfortunately for me, on this timing base, there's supposed to be a white wire, and on the CDI one that you had in all the videos online, you see there's a white wire, but this one is actually had rubbed off on a couple of the other wires and became a yellowish color, and it's hard to actually see what color it is, but this was or is the white wire. You can follow it up into this harness and see that there's three pins on the bottom here, and then one in the center. And so the pin that you are looking for is the one on the bottom row of 3 and in the center. So I'll plug my one of my leads into that guy, and then so that is on your sheet. That was the white wire, and I'll just use the other one for simplicity. But on the actual sheet it says purple wire second connector. So this is the second connector. There is a purple wire, and it goes up to the top. So there's once again 4 wires, and so the 3 on the bottom, which correspond to the 3 pins on the bottom, and the purple one. So what we'll do is we'll end up clipping onto the purple one, and we'll see that and according to the sheet, the typical range is between 1 million to 5 million ohms, and I'm not really seeing anything right now. So one of the tricks that you can do is you can swap your leads around, and on the good timing base, doing that actually made it show the particular ohms, but in this case there's nothing. So let's go ahead and move to the other wires, and we have nothing there, and we have nothing there. Center wire, at one time it gave me an ohm reading, but it's not today. So let's check one last time to make sure that we've got something. And it doesn't like we have anything. So unfortunately I didn't get any ohm movement out of this guy, but which, I mean, obviously it's bad. That's why I took it off. But I thought I would be able to show you that I was way under on resistance at one time. Before I pulled this off, I was at like 75 for resistance between the black wire, or the white wire, and the black white wire on this harness, and so it needed to be replaced. So that is how you test all of these parts. And so as you could see, the stator was almost within specs and could have lasted maybe another season. The timing base is completely shot now. I can't get any readings off of it. The voltages were bad. Everything was bad on this particular stator. So I hope you find this video and showing these things to you helps you out in some way. I know that I was kind of lost when I was doing all of this, and just trying to provide some lessons learned to everybody.